Hello, Algebra 1, and welcome to PA3 Part 1, Solving One-Step Equations. We're going to talk about the addition and subtraction first, then we'll talk about the multiplication and division. Get ready for some fractions there. Let's go ahead and get started. An equation is a math sentence that does contain an equal sign, unequal sign. We have been trying to get there because we've been working with expressions which do not contain the equal sign. So now we're at the equations things. The goal of solving an equation is to find the value of the variable. In other words, you're trying to get x alone, or z alone, or a little stick figure alone. You want the x equal to something, or z equal to something. You're trying to get the variable equal to something. Isolating. We do this by isolating. Isolating, kind of know a little bit about that right now. We know isolating here. We're trying to do that using inverse operations. And an inverse operation is something that undoes something. So if we take a look at that, if we're trying to do the inverse of addition, we would do subtraction. Yeah, great job. I could hear you. Subtraction. All right. And then, so if that's the case, then the inverse of subtraction would be addition. There you go. Nice job. I like it. Who says we can't be interactive? All right. The inverse of multiplication is going to be division. And then the inverse of division, if we already said, the opposite was, it's going to be multiplication, right? So, John, these are our examples, right? John has X apples. He has some unknown number of apples. If he adds 5 apples to his pile, he'll have 8 apples. What is the value of X? We can write our equation. X is our unknown plus 5 because he's adding 5 apples. Then he has a total of 8 equals 8. The opposite of addition is subtraction. We would subtract 5 from both sides of the equal sign. We would get X equals 3. All right, all right. So this means that John had 3 apples before he added to his pile to get 8. Maddie has X dollars. After spending $90 on a purse, she's going to have $45. What's the value of X? In other words, she has this amount of money that we don't know. We call that X. We take away 90, and that gives us a remainder of 45, right? X minus 90 equals 45. To solve it, the inverse operation of subtraction is addition. I would add 90 to both sides. 45 plus 90 is 135. We have isolated our variable. Let's do some of these real quick. Oh yeah, and then here's the most important part. Check your answers. That's the beauty of equations. If you get a number and then you plug it back in and it's not equal, you did something wrong somewhere. Maybe you have the right answer but didn't do the right steps in order of operations. But you can always check your answer. Then if it's not working out quite right, we can figure that out. In the apples example, we said he had 3 apples, then added 5. 3 plus 5 does equal 8. In the purse example, $135 she had before, spent $90. If I take away 90 from 135, I do get 45. What does that look like down here? Well, X plus 2 equals 10. The opposite of addition is subtraction, and so instead I'm going to take 2 away. And plus 2 minus 2, 0. That's where the 0 bit comes in. And 10 minus 2 is 8. In other words, we're saying X equals 8. If we were to check that, does 8 plus 2 equal 10? Yeah, it does. We're good to go. Y minus 8 equals 15. We're trying to get the y by itself. That's the variable that we're trying to get by itself. I'm subtracting 8. The inverse of operation of subtraction is addition. There you go. There you go. Add 8 to both sides. Negative 8 plus 8, or minus 8 plus 8 is 0. 15 plus 8 is 23. We're trying to say that y is 23. Well, does this work out? Let's see. If I plug in 23 for y, 23 minus 8, does that equal 15? Does 23 minus 8 equal 15? Yeah. In fact, it does. Example 3, take a look at this guy real quick. This one says a plus 9 equals 2. Opposite of addition is subtraction. Plus 9 minus 9 is 0. It's just left with a. 2 minus 9, a positive 2, and a negative 9 combined when I'm doing addition and subtraction is going to give me negative 7. So I say a is negative 7. Let's check that. Does negative 7 plus 9 equal 2? Well, I go negative 7, but I'm going to come back 9 from 0, or from that negative 7. I'm going to be positive. I've got more positive than negative by 2. Sure enough, that's exactly what we got. Okay, that's the quick one, right? The addition and subtraction in one-step equations is the quick one. Do these. Show your work. Show work. Even check some of them, all right? Show your work. Show that you subtract 7 from both sides and you get x equals 11. Show that work. Show that work, okay? You can do this. But Mr. Brayman, what happens when it's on the other side? Well, you're still trying to isolate y, like in number 3, right? If I'm trying to isolate y, I want to get y by itself. Well, what's happening to y? I'm taking away 17. I'm subtracting 17. What's the inverse operation of subtraction? Addition. There you go. There you go. Add 17 to both sides. And I get 100 equals y. That's more like a g. Y. 100 equals y. You could flip that around, right? As long as you keep the same stuff on each side of the equal sign. So we could also put y equals 100. Does it matter, Mr. Brayman, if I put it 100 equals y or y equals 100? Nope. As long as you got the variable by itself. That's the most important part. So this is the big part we're trying to get to now. Okay? So go ahead and take a minute, do any of that practice you need to. And if you've done that practice, let's go ahead and get started again on multiplication and division. Remember the goal. The goal of solving these equations is to get the variable alone. To get the variable alone. That is the goal. We want to get x by itself, or z by itself, or y, or a, or j, or the, a little cat. It doesn't matter. It's just a symbol that represents something that we don't know yet. Okay? To do this, what do we need to do? We need to isolate the variable. And what do we use? We use inverse operations. You guys are being really interactive today. I really appreciate that. Inverse operations. All right. So let's take a second and review. What is the inverse operation of adding 23? Well, the inverse operation of addition is subtraction, so I would subtract 23. If I've got subtracting 18, if I've got like x minus 18, the inverse operation to get rid of that subtracting 18 would be to add 18. And now we're into that multiplication and division part, right? That's this part. If I'm trying to get rid of multiplication, if I'm multiplying by a negative 15, if I want to get rid of that multiplication, I need to divide by negative 15. And if I'm dividing by 8, the way to get rid of division is to multiply. So I would have to multiply by 8. Okay, what does that look like? What does that look like? So basically we got some steps we can follow, right? Where is the variable? What's done to it? How do I undo that and do it to both sides? The reason we're doing one step is so we can make sure we're good on one step to be good on two step. I know you've seen both, but that's okay. Let's make sure we hammer that down, okay? Where is the variable? The variable is right here. And if you remember, if you've got a number next to a letter, a variable, right? What we call that is multiplication. If you don't see anything, if you don't see a symbol in there that you recognize, it's multiplication. 8x means 8 times x. And to get rid of multiplication, I do division. I do division. And then 56 divided by 8 is 7. And I need to check my answers. Hold on, let me move this up a little bit. We said that x equals 7. So anywhere I see x in the original equation, I'm instead going to put 7. 8 times 7. Does 8 times 7 equal 56? It sure does. 56 always equals 56. Let's go on to the next one. We've got a over 5 equals 12. Now, I said it differently just to see if we could, hear that in your mind. A over 5, you could also read that as a divided by 5. Ooh, a divided by 5. This you could say divided by. A divided by 5. Well, we know that the inverse operation of division is multiplication, and if I'm dividing by 5, to get rid of it, I need to multiply by 5. And here's how this works. I'm going to show you this left side real quick. Well, let's do this. 12 times 5 is 60, okay? But here's how this works. 5 times a divided by 5. Now, this 5 that I'm multiplying, let's make it a fraction, right? If I want to make it a fraction but keep it the same, I'm going to put it over 1. And you might be seeing this, you might already realize this, but this is why it works. This could give me 5a divided by 5. Let's see, 5 divided by 5 is 1, and that's the whole purpose. Because now we've got 1a, or we just write a. Or you could think about the simplification. 5 divided by 5 is 1, and I'm just left with 1 times a divided by 1 times 1. A divided by 1, a. There we go. Check. How do we check it? We write the original equation. We substitute for the variable. We said a was 60. And does 60 divided by 5 equal 12? Yes. Yes, it does. That is how we check our work. Now, here's what I want you guys to do now. This is the part that I think we need the most work on. So what I'm going to have you guys do now is to start to look at practice 1. Take out any questions that you can find in practice 1 and just start practicing any of them. Part 2, I'm going to dedicate just to this fraction business here. Okay? So take care of any practice you want to for part 1. That practice 1 is not due until Friday, but I've already posted it online if you want to take a look at it. Okay, we'll see you back here for the next one.